Or we start? Oh, we started. It was delayed. Well, hello. As you can tell today, my nose is running, and I gotta stuff toilet paper up it, or else it's a faucet. So if if we're lucky, you might get to see me replace it if it gets too saturated, but we'll see. All right. 2.4. Interesting. I just opened it up because I don't plan ahead when I do these videos, but it's called Clearing Fractions. Now, in all my years of mathematics, never have I ever heard of clearing fractions. Um, but as a concept, but I do looking at this example, I do know what they're doing, and it's a nice little shortcut. Now, here's the thing about math shortcuts. It's a way to do it. It's not the only way to do it, and you don't have to do it. But it certainly has its benefits and the right settings. So let's actually, hold on, let me see if I remember how to pause this thing. No. No. Okay, found it. Anyway. Um, yeah, so clearing fractions, let's go ahead and get started, and we'll do the example 2.4a on page 59. I'll show you the method, I'll explain why it works, and then I'll show you how to do it the other way if you don't want to do it that way. So, okay, I had a change of heart. I'm going to show you the normal way, and then I'll show you the shortcut. So, if we have a problem like this, we are trying to solve for our variable, which means get our variable by itself. So let's go through the standard procedure. We read it first, 5 times x divided by 8, or you could say 5/8 times x plus 1/4 equals 4. What's happening to x? It's being multiplied and then added. What do we do first? We're trying to undo everything to get x by itself, so we're going to do PEMDAS backwards. So we're going to start with addition and subtraction. So how do we undo addition by 1/4? We subtract by 1/4. What we do to one side, we got to do to the other. I'll go ahead and put it up here for this case. We have two fractions. We can only add fractions if they have the same denominator. Make this a fraction. We have 4/1. To change the denominator to 4, we do multiply both sides by 4. We get 16/4. 16 minus 1 equals 15, and then over 4. So now we have, these cancel. We're left with 5x8 equals 15/4. What's happening to x? It's being multiplied by 5/8. How do we undo 5/8? We multiply by its reciprocal, which is 8/5. What we do to one side, we do to the other. Cancel, 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 cancel. We're left with x on the left. 4 and 8 both have a 4 in common. 4 goes into 4 once, 4 goes into 8 twice. 5 and 15 both have a 5 in common. 5 goes into 5 once, 5 goes into 15 3 times. We're left with 3 times 2 is 6. Okay, now that was it was all right. We know how to solve a problem like that. The most time-consuming part is right up here when we have the fraction subtraction. Obviously, I skipped a few steps because you all know how to do that on your own if you have enough time. I'm just trying to speed it up. Now, and then we just use reciprocal multiplication, which is always fun. Anyway, so that's how we normally would approach a problem like this. This concept is called clearing fractions. So let's see how this is going to work. So clearing fractions comes into play when we notice that we have more than one fraction in our problem. So we have a fraction right here, 5/8, and we have a fraction right here, 1/4. And what we can do is we can try to remove the denominators through multiplication. And so, for example, it's a bit of a strange concept to explain right now, but once I show you what it does, you'll make more sense of it. So first of all, we want to look at all right, I completely forget where we were because I had to step away for a few minutes. But okay, so we use clearing fractions whenever we notice we have multiple fractions in our problem. And so we want to look at the denominators. So what denominators do we have on all the fractions? Well, we have an 8 and we have a 4. So just like when we are adding and subtracting fractions, we want to know what the greatest common multiple, or yeah, least common multiple is um, between 8 and 4. So think about that for a second. What is it? It's 8. So let's take 8, and this is what we're going to do. We're going to multiply 8 by everything. And that might seem a little strange, but let's see what it accomplishes. So we got it set up. Notice how I set up the multiplication as distribution. And the reason we're doing this is just because we want to make sure we're multiplying it once by every side. So we set it up like distribution, so we know we do it the right way. Let's go ahead and start with the right side. 8 times 4 gives us 32. Now let's take a look at the right. Distribution says we're going to multiply the number on the outside by everything, or once by everything on the inside. So we have 8 times 5x over 8, and if it helps you, you can, since we're doing fraction multiplication, we can think of this as 8 over 1. So what do you notice about 5x over 8 times 8? Well, the 8's cancel. What are we left with? We're left with 5x. And let's do the same thing. 8 over 1, we're still multiplying by 8 because that's how distribution works. Remember, we have 8 over 1 times 1 over 4. What can we do with this? Well, we have a common multiple of 4. 4 goes into 4 once. 4 goes into 8 twice. What are we left with? We're left with positive 2. So look, this is the problem we have now. We have 5x plus 2 equals 32. So by doing this clearing of fractions, we were able to turn this big old fraction problem, well, not big old, but turn all these fractions into whole numbers, which are a lot easier to work with. And let's solve this problem normally. We got 5x plus 2 equals 32. We need to get x by itself, so we need to undo everything. And since we're undoing, we're going to do PEMDAS backwards, so we'll start with addition and subtraction. What's the opposite of adding by 2, subtracting by 2? What we do to one side, we'll do to the other. These things cancel. We're left with 5x. 32 minus 2 equals 30. 5x equals 30. Multiply both sides by 5. X equals 6. So from here to here was a lot simpler than having to do finding the least common multiple, subtracting, and then getting down here and using the reciprocals and canceling and getting the 6. And especially when it's an easy number like 8, we know we can just cancel all these real quick. Well, not exactly cancel, but we can turn these different fractions into whole numbers, and it's usually going to be easier to work with. Now notice, it didn't matter whether we did it this way or this way, we still got to x over 6. So in these cases, it's really up to you whether you want to do this clearing of fractions or not. But if you see an easy way to do it, go ahead and set up your distribution, and you can do it that way. All right, we got y divided by 6 plus y divided by 2 equals 10 over 3. This might be a little daunting, but let's just go through our process. Let's use our clearing of fractions. I don't like that name. If we think of a better name, let me know, because I'd rather use that. So let's see if we can get rid of, what tips us off is that we have multiple fractions. And in this case, all of them are in a fraction. So if we can get rid of the fractions, we can work with everything a little bit easier. So we want to ask the question, what's the least common multiple between 6, 2, and 3? Pause and think about it. And the answer is 6, of course. So since 6 is the least common multiple, we want to multiply 6 by everything. And just like last time, we'll set it up like a distribution problem. Well, let me phrase it like this. What we want to do is put our left side in parentheses. So put the whole, rewrite everything, just put it in parentheses. And then do the same thing for the right, rewrite everything, and then put it in parentheses. Now on the outside of the parentheses, we'll put our least common multiple, 6 and 6. So on the right, we have 6 over 1 times 10 over 3. What do the tops and bottoms have in common factor-wise? They both have a 3. 3 goes into 3 once, 3 goes into 6 twice. We got 2 times 10 equals 20. And then on the left, 6 and 6 cancel. All we're left with is y. And then over here, even though I have that cross through it, we still have to start fresh, right? So we got 6 over 1 times y over 2. 2 goes into 2 once, 2 goes into 6 3 times. We're left with 3 times y. All right, this looks like less scary. Let's add our y's together. 1y plus 3y's gives us 4y's. Nothing changed on the right. How do we undo multiplication by 4? We divide by 4, divide both sides by 4. We're left with y equals 5. All right, let's do the same over here. And I know I said that you can get by just doing it the normal way, and that's true. But when you see, it's a good habit to just get rid of the fractions. You can still do it the other way, but it's a lot less to wrap your mind around if you get all the fractions out in the beginning as opposed to dealing with them later. So let's look at everything. So even though this only has one fraction, because our variable's in two spots, it kind of complicates it, but because we have a fraction, let's go ahead and get rid of it. So let's look at all our denominators. We only have one with the denominator. What's the least common multiple of all the denominators? Well, we only have 1, 3, so we're going to multiply everything by 3. So like I said, we're going to rewrite the left side, put in parentheses, put a 3 on the outside, rewrite the right side, put in parentheses, put a 3 on the outside. This 3 cancels with this 3. We're just left with x plus 1. And then our 3 comes back for our next multiplication. We got 3 times negative x gives us negative 3x. And then 3 times 3 gives us 9. We want to combine like terms. We have x minus 3x, which gives us negative 2x. Nothing happened to the 1 equals 9. And now we're just left with the normal algebra. You all should know the thought process by now. Well, how do we undo addition by 1, subtract by 1? What we do on one side, we'll do to the other. Cancel, cancel. We're left with negative 2x equals 8. Negative 2x equals 8. How do we undo multiplication by negative 2? Divide by negative 2. Cancel, we're left with x. What we do to one side, we'll do to the other. What's 8 divided by 2? 4. We have an odd amount of negatives, negative 4. And then lastly, whoa, this looks kind of complicated. Kind of, but let's just get rid of our fractions. Let's take a look at all of them. We got a denominator of 2, 3, and 1. What's the least common multiple of 2, 3, and 1? 6. So just like before, we're going to rewrite our left side. Put in parentheses. Multiply by our least common multiple. Rewrite our right side. Is that a negative 8? It is. Put in parentheses. Multiply by 6. Another way we can think about this right here, well, I mean, never mind, that's a bad habit to get into. So remember how we can kind of treat our numerators and denominators as if they're parentheses too. That's going to come into play right here. Because what's happening, let's magnify. Let's do a little magnification. So right now we have 6 over 1 times 3x minus 1 over 2. So 6 and 2, they both have a 2 in common. This becomes 1, this becomes 3. And now we're left with 3 times 3x minus 1. 3 times 3x minus 1. We're going to have to do some distribution again here. 3 times 3x gives us 9x. 3 times negative 1 gives us negative 3. So we're kind of doing 2 steps in this one step here, but just when you come into these problems, just take it slow. Write it in other places if you need to. Keep your organization, because if you try to do all these steps in your head this early on in your math career, you're going to mess up. Okay, so we know that this first term becomes 9x minus 3. And let's do the same thing with our second one. This 3 goes into 3 once, 3 goes into 6 twice, and now we're left with a distribution of 2 into this 4x plus 3. So think of it as 2 times 4x gives us 8x, 2 times 3 gives us 6. Ooh, forgot the x. And then on the left we got 6 times 8 is 42. We have one negative, which means we have negative 42. All right, on the left we want to combine like terms. 9x's plus 8x's gives us 17x's. Negative 3 plus 6 gives us 3 equals negative 42. How do we undo? We subtract a 3 from both sides. We're left with 17x equals negative 45. And then divide both sides by 17. X equals negative 45 over 17 because 17 and 45 have no factors in common. That's it for this lesson. It might be a little tricky to wrap your mind around it, but the point is we want to get rid of our fractions early. That way we don't have to deal with them later. All right, bye.